We can paint the world a beautiful picture, holding out for everyone to view.
We are on our last page in the packet, graphing inequalities. We have everything we need to graph an inequality, okay? And the main thing with graphing inequalities is the details. So those of you who tend to neglect the details might have to work a little harder at this, okay? First of all, let's think about how we would answer the first couple of questions there. How would you know if 310 is a solution to the inequality given? What would you do to find out? Hopefully you know that you would just plug in those points. This is my y, this is my x. So is 10 greater than 3 plus 5? And the answer is yes. Okay? So this one is a yes. Is -1 minus 2 times -3 less than or equal to 6? That also will become yes, right? Because I'm going to have -1 plus 6, so that's going to be 5. Okay, so to graph linear inequalities, we basically do the same thing that we do to graph a linear equation with lots of extra steps. We have to think about shading the region that's a solution, because remember, an inequality has an infinite number of solutions. And we test a point and we show our test point. We have to watch the boundary line and determine whether it's dotted or solid. And the difference is it's solid if it's a similar type inequality that has a solid dot, and it's a dotted line. Okay, so we're going to use a dashed dotted something line like this if it would be an open circle. So if it's less than or greater than. Okay? So other than that, it's pretty straightforward. So how do I graph this line? Well, the slope is 1. The y-intercept is 5. So 3, 4, 5. And then I just graph a slope of 1. So my things are kind of small, so I'm going to use this, and then I would graph my line. Now the first thing I look at is it, I'm telling you right now, pencil is key here. Those of you who like to use pen, don't. I make the mistake all the time, and I have to go back and make it dashed. Okay, this in fact is a dashed line. Okay, so when I select it here, I would select my dashed line. About there, okay? And I will make sure to put in my arrows. And the thing I need to be careful of, now I'm shading on one side or another of the line. It's saying y is greater than x plus 5, so I think I'm shading. What I mean by shading is this is what we do. We're shading an area above or below the line, or to the right or the left of the line. You do have to test a point. So you show test and you pick an easy point to test. So let's say I pick 0, 10. Okay? Is 10 greater than 0 plus 5? Check, it is. So I shaded the right region, and then I write my equation here. Y is greater than x plus 5. So a lot of details. You got to think about which place you're shading. You got to do your test point. You got to think about, is this line dashed or solid? There's a lot of things you got to do. You got to remember to label it. Got to remember to put arrows. Okay? Let's try another one. Y is less than 3x minus 2. So my slope is 3. My y-intercept is -2. Okay? And my slope is 3. So I'm going to put a couple in there. This is going to be a solid line. So I would select a solid line. You guys could just draw yours in solid. These need to be, very particular. You can't be messy here. You can't be careless. Now, do I think I'm going to the left or the right of this line? Well, y is less than. So it's probably in this area. Okay, so I want to choose a point and test it. So I'm going to test 10, 0. I pick easy things. I don't pick hard things. Okay, is 10, 0 less than or equal to 10 minus 2? Yes, 0 is less than 8. That checks. Now be careful. I don't want scribble. That's not what I want. Okay? There's a teacher at the high school that makes kids use rulers to do their shading. It needs to be like this. Kind of lines that are perpendicular to the given line, shading pretty much all the way over, neatly done, in pencil, labeling your final answer. Y is less than or equal to X minus 2. Okay, that's a complete inequality graph. So I think at this point you could probably try the next few and come back and check your answers, okay? So if you're back with me, hopefully you did these number 3 and number 4, and that's what they should look like. Check your paper. Do you have the original equation listed, noted in the solution area? Do you have arrows on your line? They are both solid lines. Did you show a test point? That is key. You have to show this, okay? And you have to show what point you're testing to be sure that you did it correctly. Okay? Why don't you pause again here if you haven't already done so and do the next 4. And I will come back with the answers. So questions 5 and 6 are up here. Again, be careful. I don't think I mentioned this before, but when you're testing your point, you need to be sure to be testing the point in the original. Okay, not in this, because if you made a mistake in that process, your answer might check, and you might have forgotten, for instance, to flip. I know none of you would forget to flip your inequality, but if in fact you had and you tested it, you're going to get a different graph. Okay, so you should have a dashed or dotted line in number 5. You should have arrows on that dashed or dotted line. You should have shaded to the left, and you should have your inequality listed and tested a point. Number 6 is also there. I don't know why this guy moved down, but he's the arrow on my line. Okay. Then in numbers 7 and 8, they look like this, some fun fractions just to test the waters, okay? And that's what those look like. I tested points in my original equations. I chose numbers that were easy to use, okay? So hopefully this went pretty straightforward. It's the details that usually get students on these. Okay, and then you have a couple other problems to work on that other sheet, I believe, and we're going to be basically finishing up graphing. So great job. I'll see you all tomorrow.